Curves in industrial design. The Boor algorithm. The points on a cubic B-spline curve can be written as C, T, 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 where C with 3 entries is the polar form of the B-spline curve, and T is in the allowed range for the parameter. That means T lies between the third and third to last nodes in the blossom knot vector. The points on the B-spline curve can be obtained through an algorithm called the Boor algorithm. The Boor algorithm is analogous to the Castelliot algorithm that generates Bezier curves. The Boor algorithm is based on the symmetry and multi-affinity of the blossom. We'll see now a schematic representation of the Boor algorithm. The Boor algorithm takes a barycentric combination of 2 points to obtain a third point. We'll represent this by this graphic, where the point C0, 1, 1.5 is obtained as a barycentric combination of the points C0, 0, 1 and C0, 1, 2. In the representation above, the points C0, 0, 1 and C0, 1, 2 lie on the line parameterized as C0, 1, T. This is the polar with 2 fixed entries and 1 free entry. The point C0, 1, 1.5 also lies on the same line. So we see here that the point C0, 1, 1.5 lies on the line segment defined by C0, 0, 1 and C0, 1, 2. In fact, the point C0, 1, 1.5 divides the line segment in the same proportion as 1.5 divides the segment between 0 and 2. That means the distance of these 2 points divided by the distance of these 2 points is equal to the distance of those 2 points divided by the distance of these 2 points. This is due to the fact that the polar form is affine and symmetric. So the point C0, 1, 1.5 can be written as a barycentric combination of the point C0, 0, 1 and C0, 1, 2, where these are the coefficients of the barycentric combination that are given by these values. So we will use this schematic representation to show how the Boor algorithm will work to find the point for t equals 1.5. That means to find the polar point given by c 1.5, 1.5, 5.5. This is a point on the B-spline curve which has knot vector 0, 0, 0, 1, 2, 3, 3, 3. The first observation is that since 1.5 lies between 1 and 2, these 2 entries of the knot vector, the starting vertices of the algorithm are those whose polar forms have either 1 or 2 in their entries. So we don't need to use the first control vertex of the B-spline curve nor the last control vertex of the B-spline curve for this situation. In this case. In other cases, we'll use those either one. So in the first stage of the Boor algorithm, from these initial 4 points, we obtain 3 points. Each of them will have 1.5 as one of their entries. You can observe it has here, here, and here. The first point of the first stage of the Boor algorithm is obtained as a barycentric combination of these 2 points. That means this point lies on the line segment defined by these 2 points in the same proportion as 1.5 lies between 0 and 2. This point here lies on the line segment defined by these 2 points on the same proportion as 1.5 lies between 0 and 3, in this case in the middle. This point here lies on the line segment defined by these 2 points on the same proportion as 1.5 lies between 1 and 3, closer to this point than to this point. The second stage of the Boor algorithm now gives 2 points. The first point is a barycentric combination of these 2 points. Observe that for the second stage of the Boor algorithm, every point has 2 entries equal to 1.5 in the polar form. So this point is a barycentric combination of these 2 points, lies on the line segment defined by these 2 points, on the same proportion as 1.5 lies between 0 and 2, in this case closer to this point than to this point. This point lies on the line segment defined by these 2 points, in the same proportion as 1.5 lies between 1 and 3, closer to this point than to this point. And finally, in the last stage of the Boor algorithm, we obtain the last point of the Boor algorithm, the point of the curve, which is the polar form evaluated at 1.5 3 times. This point lies on the line segment defined by these 2 points, in the same proportion as 1.5 lies between 1 and 2, in this case in the middle. So we will see the Boor algorithm acting on the curve. So we have the same node vector. These are the control vertices of the control polygon of the B-spline curve. And we want to find the point of the curve for t equals 1.5, which in polar form has this representation. So in the first stage of the Boor algorithm, we get 3 points. The first point, which lies on the line segment defined by these 2 points, the second point on the line segment defined by these 2 points, and finally the third point on the line segment by these 2 points, in the proportions given by the ratios 1.5 between 0 and 2, and so on, as we saw before. The second stage of the Boor algorithm, we get 2 points, lying on the line segments defined by these 2 points. These 2 points is 1, and these 2 points is 1. And the last point, the third stage of the Boor algorithm, is a point on the line segment defined by these 2 points, which is a point on the curve.